Welcome to Zaption Tour 4.4, Graphing a Function Rule. There are 7 boxes. The essential understanding of section 4.4 is this. It says the set of all solutions forms the equation graph. A graph may include solutions that do not appear on a table. So basically we're going to be talking about the set of all solutions to a particular equation, and that's what makes up the graph, not just little points on the way, not just little points along the way. This is why we draw the line on the graph, because sometimes the graph has solutions that's not in the table, and real world graphs should only include points that make sense on a given situation. We're going to talk all about that in this tour. Box number 1 is an example. It says, write the graph of, or what is the graph of the function rule y equals negative 2x plus 1. So I want you to do this in 2 steps. Step 1, I want you to make a short table. So we'll do x, and then we'll do y is equal to negative 2x plus 1, and then we'll do the x, y coordinate, okay? So make a short little table. So we'll go negative 1, 0, and 1, a short little table. So plugging in negative 1, I would get negative 2 times negative 1, and then add 1. Negative 2 times negative 1 is positive 2. 2 plus 1 is 3, so I'm thinking it's negative 1 comma 3. Plug in a 0, I would get negative 2 times 0 plus 1. That would just give me 1, so 0 comma 1. And plug in a 1. Negative 2 times 1 plus 1. Negative 2 plus 1 is negative 1, so I'd have 1 comma negative 1. Then go over to your graph and plot your ordered pairs. So negative 1 comma 3, negative 1 comma 3, that'd be up here. 0 comma 1, that would be here. And then 1 negative 1, that would be there. And then I would connect the line that goes through these points, because any point on this line is a solution to the equation, and that's what makes up the graph. Box number 2 that you try. It says, what is the graph of the function rule y equals 1/2 x minus 1? I want you to do the same 2 steps, make a short table, and I've already given you the table, and then make the graph. Hopefully you got the right answer, but if you do not, the 3 points that we get from plugging in negative 2, 0, and 2 would be negative 2, 2, 0, negative 1, 2, 0. When you plot all those on the coordinate graph over here, on the coordinate plane, you get a nice line that goes through those 3 points, indicating the graph of the equation. Box number 3 is an example. It says, real world function rule. The example is trucking. The function rule W equals 146C plus 30,000 represents the total weight, W, in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 cubic feet, what is a reasonable graph of the function rule? Okay, so we're going to step 1, we're going to make a table and find some ordered pairs. So here's the table that I have set up. I have C over here, and that stands for the variable cubic feet of concrete. We have W, the way that the function rule has been defined, okay? And then we have ordered pairs over here, C comma W. Now I've plugged in a few of them. I plugged in 0 and 50, and I'm going to go ahead and fill in the rest of the table really quickly. Okay, I just used my calculator in the table feature to fill in the rest. But then it says, what would the graph look like? So we have to only consider concrete up to 200. We can't go any more than 200 because it says it has a capacity of that, of 200 cubic feet. So at 0, I would be up here at 30,000. Okay, at 50, I would be at like about 37,300, so right about here, I suppose. 100 would be about 44.6, so that would be right about here. Okay, at 150, we'd be at 51. Sorry about there. And then at 200, we'd be almost at 59. So if I did that somewhat correctly, you know, I would have a line that would look something like this. This would be a linear function, and this is what the graph would look. I'd be comparing concrete to total weight. Box number 4 is the idea of continuous versus discrete graphs. So on the left, I have a continuous graph is a graph that is unbroken. It's a line. It looks like this. It's what you would think exactly a line should look like. That would be continuous. Discrete is a graph that is composed of distinct isolated points. So I have these distinct isolated points along the way. There is no value in between 2 points for which I can get an output, versus between any 2 points I could find a lot of different values and get an output. This is the difference between continuous and discrete. Box number 5 is called Farmer's Market. It says a local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown below. Write a function for the situation, graph each function. Is it continuous or discrete? Okay, so I have 2 pictures of the situations here below. I'm going to walk you through both of them. All right, I'll make it a little bit bigger for us to see. 1 gallon of milk makes 16 ounces of cheddar cheese. Says, so the weight W of cheese in ounces depends on the number of gallons milk used. So they give us a function rule. So W equals 16M, and then we make the tables. So M stands for milk, gallons of milk. W is the weight of the cheese. Okay, over here, it says the amount of A, money made from the selling, depends on the number of wheels sold. So the amount is equal to 9N. Make a table of values. So if I sell 0 wheels of cheese, then I make $0. If I sell 1 wheel of cheese, I make $9, and so on and so forth. Let's take a look at their graphs. By the graphs alone, you should be able to tell which one is continuous and which one is discrete. When we look at the weight of cheese graph, when we take milk versus weight, well, I could have 1.5 gallons of milk, and therefore I could figure out exactly the weight that I would want to use to make my cheese. However, I could not sell 1.5 wheels of cheese. It just doesn't make any sense. So therefore, the weight of cheese graph is continuous, and the money earned graph is discrete. Box number 6 is a you try. It says, is the situation continuous or discrete? Justify your answers. Hopefully you got the right answer. Part A is continuous because the pool is filling up, and it can be filled, and it can fill up. I could stop it at any point. Like I could stop it after 2.5 seconds, or I could stop it after 10.5 minutes, so on and so forth. However, part B is discrete because I can only sell 1 ticket at a time. So the cost that I'm going to sell depends on the number of tickets, or the cost that for the tickets depends on how many I want to buy. So I can't buy 2.76 tickets. It doesn't make any sense. Therefore, that would be discrete. Box number 7 is graphing non-linear function rules. Sometimes the graphs that we're going to create are not going to be lines. They're going to be something else. So we want to be able to look at those and recognize those as well. Part A says y is the absolute value of x minus 4. So we'll do the same approach. We'll take a couple of test points, plug it in, and get some coordinates that we can plot on the graph. So plugging in, if I plug in a -1, I would say the absolute value of -1 and then minus 4. The absolute value of -1 is 1. 1 minus 4 is a value of -3. So I would have -1 comma -3. Absolute value of 0 minus 4 would just give me -4. So I would have 0 comma -4. And then absolute value of 1 minus 4 would give me -3 as well. So 1 comma -3. So take that information and then plug it onto the graph. So -1, -3 is on the graph. 0, -4, and 1, 3 is on the graph. So this particular graph makes a V shaped, and we're going to study this graph in depth later. But for now, all you have to know is that this is non-linear. And you can see the real graph in real time over here when I graph it for you. So there it is, absolute value of x minus 4. When I put that onto the grid, you could see that it goes on forever and ever. And this is a non-linear graph.